Everyone says testers need AI, but I think AI need testers. And in the next 20 minutes, I'm going to show you exactly why. This is Morning Zero of Get Started with AI for QE in 2026, my new playlist on the MK Labs. If you watch the trilogy on this channel, video 1, 2, and 3, those are the what of testing AI. This one is the who. It's about why you specifically, coming from a quality engineering background, are unusually well positioned to do AI engineering. Better than most backend hires walking into the same room. So stay tuned. 4 reasons, less than 20 minutes, no prerequisites. Welcome to MK Labs. Let's get into it. Before we touch any vocabulary, prompt engineering, RAG, agents, and evals, I want to spend a few minutes on the question that actually matters the most. The one most courses skip. Are you, the QE practitioner, even in a position to do this work? The honest answer, the one I've earned over a couple of decades in quality engineering and a few years building AI system is yes. You're more than in a position, you're unusually well positioned for it. Better than most backend engineers, candidly. And in the next few minutes, we are going to show you exactly why. Before we touch any vocabulary like prompt engineering, RAGs, agents, and eval, I want to spend a few minutes on the question that actually matters the most. The one that most courses skip. Are you the QE practitioner even in a position to do such a job? The honest answer is the one that I've earned over a couple of decades in quality engineering is still even relevant. The answer is yes, you are actually unusually well positioned for this role. And in the next few minutes, I'm going to exactly show you why and how you can be even more confident than ever. Let's get into it. I'll give you 4 reasons, 4 reflexes you already have from your years of QE experience that map almost cleanly into AI engineering. You already think probabilistically, you already think about edge cases, you already think about systems, and you already classify failure modes. That's 4 or 5 hardest things to teach. The 5th is the vocabulary, is what the rest of the course handles. So today is just for 4. By the end, you will know whether you should be watching the rest of the AI engineering is really somebody else's job or you could very well handle it. Let's go. Before the 4 arguments, one shift you need to feel in your gut. Classical software is deterministic. Same input, same output every time. The systems we test on this channel or not, look at the table. You've done this before. The moment you look at it, you will understand why it is easy. Same input, sometimes different output. Tests passing doesn't mean the feature works. It means the test survived this wrong. Bug reproducibility is probabilistic. 1 in n, not 1 in 1. That's what you usually used to, but this is different. Coverage is no longer lines and branches, it's scenarios. The oracle is no longer a hard-coded expected values. It's a rubric or another model. And bugs get fixed by changing prompts or data, not just code. Same engineering rigor, different physics. Hold on to the frame for the next few minutes. One housekeeping note before we start, more courses playlists sell you on what you need to learn before AI engineering is even available to you. I'm going to tell you what you don't need. You don't need a machine learning degree or a PhD holder. You don't need to have shipped a production model. You don't need years of Python experience or expertise. You don't need to know about linear algebra or transformer math. What do you need are the 4 reflexes that come up next. You already have them. The rest of the course teaches you the vocabulary to attach to them. You're closer than what you've been told. Argument 1. You already think probabilistically, and that's the single biggest mental shift backend engineers struggle with when they come to AI. You don't, and here's why. Think about a flaky test. A test passes 49 times in a row and fails on 50. When that happens, you don't panic. You don't open a ticket saying the build is broken. You investigate the pattern. You ask, what's the failure rate? What's the difference between the runs that pass and the one that fail? You characterize the variance. That instinct, that exact instinct is what every LLM in production needs. Same prompt, same model, same day, sometimes different outputs. Backend engineers find that disorienting. They want determinism. You don't. You spent 20 years getting comfortable with variance. You're already at home in this space. You just don't know it yet. Number 2, you already think about edge cases. And honestly, This one is almost embarrassing how directly it transfers. Look at the columns on the left. That's what we call these techniques in QE. The boundary value analysis, negative test cases, input validation testing, equivalence partitioning, the bread and butter of any test design textbook, right? Now look at the right side. Adversarial testing, red teaming, prompt injection defense, eval, set design. These are not new disciplines. These are your disciplines with new names. The AI engineering world is, right this minute, is in process of reinventing test design under fancier names, fancier vocabularies. You have had this reflex since your first negative test case. The work is to learn what the new names are, what the differences are real. The reflex, it's already yours. Number three, you already think about systems. Before I show you what this looks like in AI, I want you to credentialize the claim. Let me prove to you concretely that you're already a systems thinker. 5 things you do every week. 1. You trace bugs across boundaries. UI shows the wrong number. You didn't blame the AI. You walk it back through the API, the database, the upstream service, and you trace the path. You don't blame the surface there. 2. You ask why fixed bugs come back. You don't just close tickets. You ask what the other part could trigger this. 3. You read flaky tests as signal. You look at timing, the state, the concurrency, whether it's an environment failure. That variance identification is huge information. Most engineers want it gone usually, but you want to understand and fix it. Excuse the self-heal part. Let's come to that later. But you want to fix the flaky test, don't you? Number 4. You design test environments, production-like data, network conditions, dependencies. The model system tests the design. 5. You predict Black's radius, small change, what regression risks opens up, how you could make sure the change doesn't hit your production, and how you can question the developers didn't, right? That's system thinking. After 10 years, you don't even know it's a skill. The AI world is desperate for it, I'm telling you. Now, here's exactly how that exact muscle landed into AI. Look at the diagram. An AI system in production is not a function, it's a chain. Retrieval pulls some data, the model generates some output based on the data. The orchestration routes the workflow, the user interprets the results. When the output is wrong, and it will be, the question is not just, was the model wrong? Did it hallucinate? The question is, where in the chain did it break? Was it retrieval, the model, the orchestration, or the interpretation? This is exactly the question you already ask when integration test fails. You don't blame the unit test. You trace the contract. An AI system is, by my definition, an integration test that you're running in production. System thinkers, that's you. You own the space. Number 4, and this is the one that might surprise you, you already classify failure models. Every QA practitioner has in their head a working bug taxonomy. Functional bugs, regressions, integration failures, usability bugs. You don't treat them the same way. Each one has its own triage path, its own owner, its own urgency. The AI world has a bug taxonomy too, in the form of hallucinations, drift, orchestration failures, trust failures. Look at the rows. They line up almost one-to-one with categories you already use. A hallucination is a functional bug. The model returned a wrong value. The drift is regression. Orchestration failure is an integration failure. Trust failure is a usability bug. You already done the hard part, the classifying. The vocabulary is what comes next. And the 5th, I didn't promise you, and I'm going to throw it in for free because it lands hardest for most senior quality engineering folks. You have been building agents for years. You just call them frameworks. Yes. You have been building agents for years and you didn't know you have been calling it frameworks. Look at the column on the left. What's in your test automation system? An orchestrator, retry, backoff, test state, fixtures, failure classifications, away, abstractable, wrappers, adapters, repeatable runs in CI, all that you have done in the test automation. Now look at the right as a modern AI agent. Again, the vocabulary, right? That's the modern AI agent. Agent loops, retry policy, agent memory, agent observability, failure classification. Same word didn't even change. Deterministic eval suites. Same design problems, different vocabulary, that's it. If you built a series test framework, you already designed an agent, you shipped it under a different name. That's it. One frame to lock in everything we covered so far. 5 reflexes, all US. The 4 engines first. Probabilistic thinking, you investigate variance instead of denying it. Edge case mindset. Boundary analysis and negative test are the adversarial reflex by default. Systems thinking. You trace failures across layers because integration test trained you to. Failure mode classification. You don't treat every bug the same. You categorize first and then get into it. And the last, the binding reflex, the critical thinking. You question what others accept. When someone says it works, you ask under what conditions. When the demo goes well, you ask what the happy path ahead. When the model sounds confident, you remember the confidence is not correctness. AI engineers are about to learn painfully what every QA practitioner has known for years. Fluency is not accuracy. A answer is not a correct answer. The instinct to question the gap is exactly what AI evaluation needs. You already have it. Let's make this concrete. Let's take an AI support bot week 3 in production. Customer asks why my refund was rejected. The bot answers fluently. Cites policy clause 4.2 does not exist. The bot made it up, right? From a backend view, the responses ship, the tests are green, latency is good, no errors logged, ship it done. From a QA point of view, it's confidently wrong. Hallucination rate around 0.5%, only visible at scale. This is the bug and this is the test suite. Never saw it coming. The shift isn't the code, it's in what counts as working. Backend engineers usually miss that bug because they're looking at status codes you want, and that's the whole pitch. And that's the whole argument in 2 lines, right? Your seniority transfers, the vocabulary doesn't. That's the whole argument in 2 lines. Your seniority transfers, the vocabulary doesn't. Every reflex I just walked you through, those took years to build. Probabilistic instinct, edge case rigor system visioning, failure mode taxonomy. The software engineers don't have those baked in. You do. The only gap between where you are right now and being employable as an AI engineer is the vocabulary. That's it. And vocabulary is the easiest gap to close because vocabulary is the cheapest thing to teach. That's exactly what this playlist is going to close in next few weeks, and then you're done. Here's how the next few weeks build on top of what you already have, the foundation. The bottom of the stack is the widest layer, is everything we just discussed. Probabilistic thinking, edge cases, system, failure modes, that's you already have and you're not paying for it. On top of that, we add AI vocabulary. The large language models, retrieval augmented generation, embeddings, agents, eval, script. These are all the technical jargons that you would have found, and sometimes you got overwhelmed on what this even means. Then the AI frameworks, like Phoenix, Langfuse, Rigor, prompt, which one should I go target? What should I do? And then the practitioner muscle, building an eval suite from scratch, shipping a runnable repository. At the very top, you can see the AI Quality Engineer 2026. That's the title, will be someone's job in next few quarters. Foundation is yours, and the next few weeks, let's learn together in building this up. Here's how the next few weeks will build on what you have. In 2 columns, what you learn, what you'll be able to do. 5 concrete chunks of vocabulary, prompt and context engineering. Let's learn about LLMs, embeddings, and RAGs. And I'll walk you through what agent is and how you can get started with building an agent in as simple as format. And then let's deep dive a little bit around line chain and line graph, for why that exists. How Selenium and Playwright is for automation. Think of line chain, line graph, Mastra. These are all agent orchestration frameworks for building agents. If you like that analogy, we're going to see a lot of that analogy throughout this playlist. And I want you to stay focused. And lastly, we'll try to have sort of a capstone where, I can open up a challenge and we all can try to solve it. And that's how you learn, right? Community, let's come together. And here is where it lands commercially. There are the 3 roles that are being hired right now. You can go and check in LinkedIn. AI engineer who designs and ships AI-powered features, who knows about RAG pipelines, graph RAG, naive RAG, agentic RAG, prompt context architecture, agent workflows. Your edge system thinking and edge cases rigor that backend hires more lack. AI Evaluator, they own the eval pipeline, design rubrics, set thresholds, run drift detections, could be AI eval engineer. And then agentic workflow engineer builds and maintains multi-step agent system orchestration tools. I'm sure most of you would have heard about when we mean AI in QE, it's about orchestration, it's about workflow. You got to use a story from Jira, you augment that user story first, and then convert into scenarios, into BDD, and then from BDD into your test cases, and then into Playwright script or Selenium script. This is a workflow, right? So how do you build that workflow? All these are wide open in 2026, and people are hiring for these roles. And you're not too late. In few weeks, let's try to solve this. A quick recap to look at how the roles are evolved. And here's where I don't want you to panic. 2020, 2025, automation testing was a career multiplier. People who got serious about it, they're not still cashing in those checks. 2015 to 2020 is DevOps. People started fiddling with Dockers and containers for Selenium Grid. Some of them have moved into DevOps role. They're cashing in checks. Same story, 2020 to 2024, cloud. Same story again. And now, going forward, it'll be the AI evaluation era. That's where more specifically I want the QA engineers, QE engineers to look at and how we can learn this skill, right? Every wave has one career multiplier. Skills are rare before they even become table stakes. The window is open for about 24 months. After that, every backend engineer with a pulse will have an AI engineer title. Go check for yourself in LinkedIn. I'm sure you would find an AI eval engineer in job post. If not, tell me. If you found it, feel free to post a comment down below. This is yours. Take it. The future isn't testing software, it's testing intelligent systems. Same craft, different surface. Subscribe. See you shortly in the next video. Until then, please do take good care of yourself.